Right, today's lesson is 5-6, Laws of Logarithms. Today's date is today. Our objective is to prove and apply laws of logs. So let's take a look and find out what these laws of the logarithms are. The first one is the product. That means if I'm taking the logarithm and I've got two factors, I can separate those two factors with a plus sign. For the second rule, if I am dividing two factors, I can separate those two factors with a minus sign. On the third one, I've got log base b of m equals log base b of n. What that one is saying is if I've got two logs that are set equal to each other and they have the same base, then what I'm taking the log of also has to be true. So m has to equal n. And the fourth one, what that one is saying is if I've got an exponent, I can move that exponent in front of the logarithm. So I'm going to have n times the log base b of m. Let's do some examples. So on the first one, first thing I want to look is, do I have the same base? I do. I have a base of 5. Then I'm going to ask myself, what are they being separated by? Well, they're being separated by a plus sign. So that is really, oops, it's not writing correctly. And I'm going to pause for just a second and recenter this board. Okay, back to our first example. I'm going to have log base 5 try that again. Well, obviously that's not writing very well right there. Let's try it over here. Log base 5, and then I'm going to take 4 times 3 and get 12. So that's the answer there. On the middle one, I'm separated by a minus sign. As soon as I see that minus sign, I'm going to start thinking about division. So that is log base 6 of 25 over 5. I'm going to have to apologize for this handwriting. This smartboard is not writing all that smart right now. So that is going to be log of 25 over 5. And if I divide that, that would be 25 divided by 5 is 5. So it's going to be log base 6 of 5. Let's look at our next example. On this one, I've got log base 4, or log base 2 of 4, plus log base 2 of 2, plus log base 2 of 8. On that one, pretty much anything that has a minus sign is going to go down in the denominator, because that tells me that's what I'm dividing by. So it's going to be log base 2, and on the top is 4 times 2, on the bottom is 8. So I would have log base 2 of 1. You might be thinking that we're done. I'm thinking that we can simplify that just a little bit. If I set that equal to x and write that in exponential form, 2 to the x equals 1, from my rules of exponents, I know that anything to the 0 power is 1. Therefore, x has to be 0. So, log base 2 of 1 is 0. All right, on our next example, the first thing I'm going to do is move my exponents Take that 5 and make it into an exponent. Move that 2 and make it into an exponent. Well, I have a log base 7 and a log base 7 on both sides of the equal sign with nothing else around them. So I can say x to the 5th equals x squared. I'm going to go ahead and solve that. Let's subtract that x squared from both sides. I don't really want to divide both sides by x squared because I can lose a root. I have a greatest common factor here. Take each of those factors, set it equal to 0, and you're going to get x equals 0 and x equals 1. Again, I just took each of those factors and I set it equal to 0. In your calculator, though, you might want to go back and double check and make sure we don't have a false answer here. Take your calculator and take the log of 0 and see what happens. You get a domain error. That's because when we started off and we graphed, remember how I said it never crosses that x-axis? It doesn't cross it. So 0 will not work. X equals 1. All right, 2 more. This will be log base 4, 60 on top. 4 is going to be in the denominator because there's a minus sign. And when I simplify that, I get log base 4 of 15x. This is a common log, and the reason that I know it's a common log is there's no subscript, so it's 10. And again on this one, 3 in the denominator, 6 on top. Looks like I can just cancel right there. And I get log of 14. On these ones, I want to expand each logarithm and simplify if possible. When it says expand, we want to take it out as far as possible. Well, I've got 3 factors, so I'm going to separate them all with a plus sign. Log x plus log y plus log z. On this one, it's going to be log base 2 of x, and I'm dividing by the y, so it's going to be minus log base 2 of y, and I'm also dividing by that z. All right, those are your laws of logs. I hope you enjoy. I think I was just kidding. We have a couple more examples to do. We want to express y in terms of x. Well, first thing I'm going to do is take that 2 and move it into the exponent. Well, we've got the same base, so I can say y is x squared. Here, I'm going to try and combine them. We've got a natural log this time. Move my 2. And that'll become natural log of x squared over 4. I have 2 natural logs. So what I'm taking the natural log of has to be equal. On this one, let's go ahead and move our coefficient in front to an exponent. And then I'm going to subtract log x to the 1/2 to both sides. So I get log y equals log 3 minus log x to the 1/2. Again, all I did there was I subtracted the log x to the 1/2. Let's see if we can get one log on each side. So log of y equals log of 3 over x to the 1/2. Y equals 3 over x to the 1/2. Technically, we should rationalize that denominator, but I'm going to leave it just the way it is. All right. I'm not kidding this time. We really are done. Enjoy your assignment.